Las Vegas is the largest city in the world established after 1900. We've had massive growth, so the Springs Preserve became a catalyst for our community to reflect on where we came from, but also talk about where we want to go into the future.
The Missouri Department of Natural Resources, Lewis and Clark building, became the first LEED Platinum state office building on a standard state office building budget in America.
The Botanic Garden invites people into the building to see how research is done, how science is progressing. It's big science on display.
When you look at the fact that well over 90% of the buildings that will be in New York City in 2030 already exist, it's not enough just to build new efficiently.
The buildings are teachers themselves. How we take care of each other and this place has become a major emphasis in weaving our curriculum together.
When we started the design of this building, we decided to use a totally different design process than we've used in the past. I'm convinced the only way you can design a super high performance building is by following this process of integrative design.
Buildings are huge users of energy, materials, water. Where we put them determines how much we need to travel around. And of course, buildings are also a slow turnover capital stock. So once you build a building the wrong way, it will continue to gobble resources for decades.
Traditionally, buildings have been created by an architect with an idea, who then gives that three-dimensional idea to a mechanical engineer, a structural engineer, a landscape architect, etc. And they say, here's the building now, heat it, cool it, put a structure around it, etc.
Integrated design requires that we start early with getting more input into the process. So a lot of times we'll be bringing people in that you would normally not be talking to until quite a bit later on in the process.
Generally, we conventionally design how a building looks and then figure out how to make it work, mechanically, electrically, sustainably, etc. This process sort of turns that inside out.
Integrative design means designing the building as a whole system and optimizing it for multiple benefits, rather than optimizing components of the building or subsystems in the building for single benefits.
I can summarize integrative design in 4 words, and they all start with E. It's everyone engaging everything early. It comes down to an oscillating rhythm of research and analysis by individuals on the team. They then come together for an all-hands team workshop to compare and look for interactions from that analysis, go off again, do more research and analysis, gather that, come back again to a workshop.
What are the implications of that type?
Always looking for key interrelationships between systems and systems components.
But I think if
integration doesn't happen instantaneously. We have to introduce issues and iterate them, but we have to allow time to consider those ideas and time to connect the dots of one idea with another idea.
Phipps opened in 1893. It was originally a gift to the city of Pittsburgh from Henry Phipps, who was one of Andrew Carnegie's partners in the steel business. This new building is for education, research, administrative offices. We're calling it the Center for Sustainable Landscapes. We actually put in an RFP that we were going to require the design team to follow facilitated integrated design. They had to agree up front that they were going to follow this process or we wouldn't accept their proposal.
The real first team activity was a one-day goal-setting workshop.
everybody gets 40 votes,
To identify those goals and prioritize them. Therefore, it's the consensus of everybody on the team, and it's very clear from the outset that we are all aligned around those initial goals.
So I think the difference is architects tend to think that they're in control of everything. And I think in the integrative design process, you have to let go of some of that control and allow things to emerge that you hadn't necessarily planned on. And that's a hard one to grapple with sometimes.
By the end of the day, everybody was like off their chairs and pens in hand and scribbling on paper and making drawings and talking about this. Hey, I'm just thinking about doing this. How will this affect your system? What do you think about this? I mean, those kinds of interactions just took place all day long. It was really incredible.
Our approach with FIPS was to minimize the overall energy consumption of the building first.
The goal we have at FIPS is to achieve a daylight autonomy of 80%. What that means is that 80% of the daylit hours, the lights should be able to be completely turned off.
If I have a really good passive high-performance envelope with really good glazing and passive controls of the sun, I can actually reduce the capacity and the requirements of my HVAC system, which means that my wires are smaller, my ducts are smaller, my pipes are smaller, my pumps are smaller, my fans are smaller. So I'm saving money on that side and reinvesting it or shifting it into my envelope.
Another option is it could be a double hung.
And so if the entire team doesn't participate in that process and understanding that one impacts the other, then you will not get the benefit of that integrated design.
I think this approach does require a lot more time up front. And you know, it was interesting. By the time we got to the construction document phase, we just flew right through that because we'd already figured out all the problems and solutions back in schematic and design development.
We'd use computer simulation of various elements of the building, the energy performance, the daylight performance, thermal comfort. It really does help refine some of our designs and inform us.
Schematic design is really when you want to do most of your load reduction analysis. So you do a computer simulation of the building's performance, trying to guide the design decision very early on. Then you start doing more serious iterative modeling runs. And the goal there is to really try and optimize the performance of the building so that you've driven the loads in that building, the heating and cooling loads, as low as you possibly can.
We still have to do fundamentally great design. We have to figure out the innovations, and then the computer simulation will help us refine it. But it does give us the ability to try things before the building is built and save us a lot of money.
So as we're changing the way we approach energy efficiency for the building, it also changes the economics. And it's really the balance of those two, obviously, that a commercial owner is going to want, how they can get the most return while reducing their costs.
One of the first nationally visible examples of an integrated design process was the Missouri Department of Natural Resources headquarters building.
Integrated design for us refers to a basic notion that no one knows as much as everyone. And so what that means is we try to get as many of the right people at the table so that each voice can be heard.
When you look at this facility and the way it was organized, what you discover is that every major form, place, shape, and material selection was a direct result of this integrated conversation.
So we're trying to find this optimization where we do have great architecture, but also high performance, meaning low energy, and great comfort. Visual comfort, thermal comfort, acoustic comfort, and we can get all of that if we work together early in the design.
Putting all the core facilities in the center allowed for displacement air, totally daylit space. It changed the basic concept of the building as a direct result of that intersection of disciplines. Daylight, energy, pedestrian comfort, all that ultimately defined the end result.
And we came up with a system of light shelves, sunshades, and structural support that's all one system. One system to serve many uses. That's when we find the cost-effective, high-performance answer.
We were a team committed to changing the lifestyle and the quality of life for all the employees at DNR. They love what they have, they're healthier because of it, and it requires less energy and so on.
2 years after the building had been occupied, I talked to the person who was running the building, and he said, you know, this building has been working wonderfully. We have in 1 month something like 2 or 3 hot cold calls. That is phenomenally low. For a building that size, the number typically would be 20 or 30. At the beginning of the design, we want to be intimately involved, where we're talking to the architects when they're making the key decisions that affect energy use, the building orientation, the size of the windows, whether or not there's overhangs, the whole building envelope. That stuff is the cheapest thing that you can do to make the building more energy efficient and perform better.
Integrative design is not simply going from here to there. There are a lot of eddies and currents going back and forth because you have to keep looping back from what you learned at each stage of the design to improve what you already did.
I liken the role of a project manager on a highly integrated project with a choreographer. You're essentially deciding when there's a big ballroom dance and everybody has to be there working together. There are times when you want just a soloist to really focus on their piece of the work. Sometimes it's 2 systems, 2 people working closely together to make one piece of the building work really well, and it's figuring out when to have those different dances occur as you move through the design process.
The Chicago Botanic Garden opened in 1972. 385 acres, 9 islands, 60 acres of water, 750,000 visitors a year, $28 million operating budget.
The project was already quite far along when we got involved, so we convened several meetings of the whole design team.
We brought on Rocky Mountain Institute in the construction document phase of the job, which I don't recommend people do.
Bringing people up to speed was really important because they had figured that, oh, we've missed all of our opportunities, and that wasn't at all the case.
The biggest energy consumption is the mechanical systems, and so we really had to sort of stop, reevaluate all the systems. So it was exciting, but also stressful and frustrating because it started late.
There were a number of items that they questioned. Why would you put a smaller chiller in the building and use that money for more energy efficient glass? So we're trading costs from one building system to another building system.
One of the issues was how much glass do you really need and where do you need it? I think the whole clear story piece in that larger entry atrium space was very interesting. When you look now at the way that both electric light and daylight are delivered to that volume, it's pretty successful.
The design team was really critical in this, in keeping an open mind and open to suggestions on their existing design that they did have a lot vested into, but they were all still very much interested in continuing to make improvements on it.
We're using a steel trellis with the photovoltaic panels as a shading device above those windows. There's a clear story glass window and glass doors, so the light penetrates into the open office area. The ceiling slopes, so the enclosed offices, light comes in, literally bounces into the open offices. That proved to be a pretty effective technique.
The Chicago Botanic Garden staff were really excited about thinking in an integrative fashion and reevaluating some of the opportunities that they may have already overlooked.
The process we went through was such a useful exercise that I could see we should have done it back at schematic design.
We came in with a healthy dose of skepticism about it, and having come to the end of it, we realized, wow, there's a lot to think about here.
We began our involvement with the building in 1961 when my grandfather Lawrence Ween, my father Peter Malkin, and Harry Helmsley bought the building. So our experience started a year before I was born. It's an incredible burden and joy to work with.
We're in the midst of a $500 million upgrade to the property that includes renovating all common areas, mechanical and electrical system upgrades, so virtually complete building-wide upgrade program.
We have to prove it's good economics.
The process actually started in May 2007 at the Clinton C40 Cities launch.
Early on, we had a large brainstorming session in which we came up with over 70 potential energy efficiency measures for the project.
In this case, it was